Hello, and thank you for joining me. My name is Paul Andrew. I'm a principal consultant and solution architect over in the UK. This will be my third SQL Day conference, I think, now speaking. So you guys obviously, you definitely enjoy the punishment of me coming to talk to you, particularly about Data Factory, which if you've probably looked at the SQL Day YouTube channel, you will have maybe seen me in the past on there as well. And today we are here to talk about Data Factory once more, this time looking at applying Data Factory in production. So let's kick off. The first thing I want to share with you is the slides. So if you want to go and grab this content and follow along, then please do so. If you go to my GitHub repository, the community events repo that's up there, there's subfolders within there for all the slides that I've shared, and there's one in there for SQL Day. So feel free to go and grab the PDF if you want to follow along. And I'll share this with you again at the very end. So let's kick off and let's actually think about our agenda for this session. Now, this is something that I always struggle with when doing 1 hour sessions now, because Data Factory, as some of you may know, it's been around since 2016 and it's matured quite significantly in that time. Of course, version 1 of Data Factory that I was using in private preview in, I think, the June of 2016 was a very different resource to what we now have available. So when it comes to talking about Data Factory, there are so many things that we could cover here, particularly when we're talking about applying Data Factory in production, which of course is hopefully the things that we're all now thinking about. So the agenda that you can see, I put some question marks on here, what do we talk about? Because there is so much in this service. So if there is something that you think that I've missed or not covered, or you've got a particular use case you want to talk about, then I'll be around after this. Maybe we can go to the networking chat area of this virtual event and we can discuss those and things as well. But what I have put into here for you, and hopefully this is my agenda for today, is a series of short stories on how we could use Data Factory in production and how we apply it. Now, the criteria or the things I've chosen to talk to you about in this session have very much been driven by what I see getting the most traction and the most traffic on my blog. So, of course, yes, Data Factory in production could mean lots of things, around testing and monitoring and security. And if those are things that you want to talk about, then yeah, let's speak afterwards. But for this session, because there's so much to get through, these are the 6 points I want to cover. And yes, I have used Data Factory pipelines for my bullet points, of course. So let's kick off then. Let's kick off with our first sort of short story around custom activities, because it's, I think, definitely a challenging area of Data Factory. It's one that people sometimes think they need to use or they might want, but they're not sure. And it's certainly, a harder part of Data Factory that you might want to have to apply or work with when you're developing. So let's take a look at custom activities firstly. And before diving into the custom activity itself, I want to introduce you to the Azure Batch service. And this will become clear as to why when we look at the custom activity. So to introduce you to the batch service as a prerequisite to our custom activity, it's a bit of a strange one. We can think about the Azure Batch service as a Venn diagram, because we love to represent all things with a Venn diagram. And we can say that we have our platform as a service technology and our infrastructure as a service technology. And the Azure Batch service, for me, very much sort of sits in the middle of those two things. I'll explain why. I'm going off on a tangent here, bear with me. So if we actually look at the Azure Batch service directly and we say, well, okay, what is in there? We have, and what we define in our batch service is a compute pool. And within that compute pool, we define nodes. And these nodes are ultimately virtual machines. And we have one node equals one virtual machine. And we define that with our operating system, our CPU, our RAM, our storage, the usual things. So we have that compute pool of virtual machines. What we can also do with the batch service here is say that if we want to, we can connect it to an Azure virtual network, and that could access our express route and get down to our on-premises infrastructure. So when I had that Venn diagram in the previous slide of infrastructure and platforms as service technology, this for me is where the batch service is interesting, because we have this compute pool of infrastructure of virtual machines. But then where the batch service is useful is that we talk to it like a platform as a service technology, and we say, here are some jobs, here are things that I want you to do. We can also schedule them if we wish, and those jobs will then run on that compute pool. And the batch service will quite happily sit there. It will use its own managed identity if we wish to authenticate against our other services, and it will do stuff for us. It will do that work using its compute pool. So that's obviously a digression. It's an introduction to the Azure batch service. And I'll say, well, why, Paul? Why are we talking about this? Well, if we bring that back to, of course, our topic of our custom activity within Data Factory, it's definitely worth understanding how we can interact with that batch service and how Data Factory can sit there above the batch service, if we like, and orchestrate our jobs, our stuff, our work. So within the context of our Data Factory, we have a pipeline, we have this custom activity. Then what we can do as happy developers, we can sit there, we can create our application, our custom code, whatever it is we want to do, and of course targeted to whichever operating system we prefer. In my case, I would probably write a C# application. I might use .NET Core to do whatever I want, but of course, you know, the choice is yours. So we do that locally, we develop that piece of code. And then within our batch service, we say to Data Factory, use my Azure batch and use some Azure blob storage. And what we do is we take that executable, that compiled piece of custom code, and we put it into our blob storage account. And then what happens is the batch service, it will use its compute pool, as I talked about in the previous slide, but of course now wrapped within our Data Factory custom activity. We can also provide it with some reference objects. So those artifacts that we have elsewhere in our Data Factory for data sets and linked services and things, we can also use those with our custom activity as well. And then at runtime, that executable, that compiled bit of code that we've written, will be taken from that blob storage account, and it will be put onto all of the compute nodes within our compute pool, which is hosted by the Azure Batch Service. It will also at runtime take those JSON artifacts, those things from our Data Factory, and it will also put them on each of those compute nodes alongside that executable. Then the code can run, you know, whatever that code is intended to do. Once upon a time, I would do this quite a lot if I wanted to take an Excel file, for example, from my customer source system and convert that Excel file to a CSV file. Now, at the time, we only had the options of using a batch custom activity to do that. Of course, Excel is now supported natively in our copy activity and our data flows as well. But you know, we did this once upon a time, and we would run this code. Our batch service can authenticate of its own accord using its own managed identity or using a service principal, or you know, interacting with Key Vault if you wish. It can maybe talk to our storage. That custom code can do whatever we need it to do, and it will run. The other thing we will get out is then a log file, and that log file will be the standard out, the standard error information that is the result of that custom code that we've written. So of course, there's quite a lot of moving parts there. And when we think about our custom activity within Data Factory, there's probably, you know, a lot of things that we might need to understand. And the way I try and describe it to people is really just comparing it to some of the more legacy or older technology that we're used to. And for me, the obvious comparison is if we're using an SSIS package. And in that SSIS package, we would create a script task, a script action within our control flow or data flow. And that script task, we would edit it, we would bring out the temporary sort of Visual Studio environment, we would put our custom code in, we would close it, we would save it, and then we would run our SIS package within our SQL Server suite of tools and services that we had. Now, because that was all wrapped up as a SQL Server package, that was very easy for us. The compiling of the code and putting it places and running it, it was taken care of for us on premises. The same thing is true here with Data Factory and with the custom activity. It's just that some of the plumbing, the connections, the configuration of that platform as a service technology, we just have to do it ourselves. So hopefully that kind of covers off a fairly painful topic that I see people struggling with quite a lot. And so creating a custom activity. And there's a link to my blog as well on the top right there, if you want to go and have a look at how to do that. So that was short story number 1. Let's move on then to another interesting area when it comes to Data Factory and controlling our production environments. So this one, of course, relates to scaling our compute. Now, just to make sure we are all on the same page, when I say scaling our compute, I want us to understand the difference between scaling up and scaling out. So I'm going to take another slight digression here. And I'm going to say that we have some work, some workload, whatever it is we need to do, and we have some compute that is going to handle that work. And we say, okay, that compute is not big enough, it's not powerful enough, we need more power, and we scale up that compute. So within that single node, we increase maybe the number of cores or the type of CPU. So scaling up. But of course, what we can also do is scale out. We can add more nodes perhaps to that cluster of work. So that's scaling out versus scaling up. And it's just something that I want to make sure we understand. Now, we can, of course, just scale out, maybe use a small amount of compute, but scale out massively. Or, as perhaps is more typical, we do a little bit of both. We scale up a little bit, we scale out a little bit. And these are the problems and things that we need to face and deal with in our cloud environment. But because we have that cloud environment, because we have this Microsoft Azure platform that is highly scalable, what does that mean for our Data Factory workloads? So instead of a generic workload as I've described it there, let's think about a workload that's perhaps more specific to what we might do from Data Factory. And what I've done here is I've just put a few of the usual suspects. So maybe an activity for a Databricks notebook, maybe a stored procedure that we run in our SQL database, maybe an Azure function that we use to process an analysis services model. And then for completeness, I've got an SSIS package here as well. So as perhaps data engineers, we go and create that pipeline to process that data, and we might use one of those activities. And that's fine, that's okay. But what I want to perhaps encourage is that if we're using Data Factory in production, that I want another pipeline, a pipeline that acts as a prerequisite to that. And what I'm going to call this pipeline is prepare environment. So for each of these activities, we could say for our Databricks notebook, do we use a job cluster? Do we ask for that compute at the point that we want to run it? If we're using a SQL database, let's have in our prepare environment pipeline something that scales up that database. We process our data. And in the case of analysis services, of course, we might want to resume that model. With our SSIS package, we might want to start the integration underneath it. Now, these things might seem obvious, and we are in this highly scalable cloud environment. And of course, we want to start these things. We want to turn them off as well when we're finished. The time to live configuration on our Databricks cluster, for example. Now, is this applicable to our data factory? Is this something that as data factory developers we should have to worry about? Now, I think for me the answer is yes, because if we're going to be good data engineers, we are going to focus, of course, on that data transformation work itself. But what I want to do is, and the point I really want to make clear, is that I want us to think about controlling our wider Azure environment as well. And just to be really clear with this point, let's say, well, why? Why do this? Now, of course, the obvious thing is to think about, well, cost. I don't actually pay for my Azure subscriptions. It's normally somebody else's problem, but cost is an obvious one. If we can do things pay as you go, or we can pre-buy that compute, why not save some cost there? But there's perhaps some other reasons that we might want to think about here. To give you a few examples and places where this has become an issue for me. With Databricks, when we're auto-scaling the nodes within that cluster, I had a scenario with one of my customers whereby they were simply running out of IP addresses. They were getting this error when they were running a notebook that says the subnet is full because their cluster was scaling out. And ultimately, the underlying VNet, where that Databricks cluster was sat, the subnet, the address range that was being used was too small. So we've, of course, now gone from a platform as a service scenario as a data engineer in Data Factory to then having this failure appearing from a Databricks notebook because that cluster was scaling out and there was not enough IP address ranges for it, IP addresses in the range for it. So, it's infrastructure as well. So that's why I say I want us to think about managing our wider environment here, not just focused on the parts within our data factory. Another example is with an Azure SQL database, and I'll show you this in my demo. It's not just about scaling it up so we have more compute. There are also some service limitations that Microsoft enforce when it comes to the number of concurrent connections that you have per service tier. So it's not just, yes, more compute, make it bigger, pay more. There are other perhaps non-functional things that you want to think about. So scaling up that SQL database so we have more parallel connections possible at the point of loading or perhaps processing our data, and scaling it back down to a level that is then acceptable for business as usual. Analysis service is an interesting one. It is a very expensive service, so of course we only want to have it turned on for the minimal amount of time. But another interesting problem I faced is that the service tiers that Microsoft give you, there is limitations on the amount of memory that you have in those service tiers. And if you're loading lots and lots of data in there, that could be a problem for you. So a scenario I've had is that we want to keep, as little data in that analysis services model as possible. But when we're loading new data, we want to keep it within that service tier. So we would scale it up to the next tier that allows more memory, create new partitions against our fact tables, load that data, and then delete the old partitions. So we're sort of entering into that service tier for the purpose of having that extra memory because those partitions have been loaded, but then purging that data and deleting those partitions so we can scale back down to the service tier we need for business as usual. So 3 examples there of things that, once you start applying this stuff in production, you need to think about. It's not just about saving cost. That said, cost is a factor. Cost is something that we, of course, do need to think about. And the question I always get asked is, well, how much does Data Factory cost? And the answer normally is, not much. It's quite a cheap service to run. And we can go into the Azure calculator and we can figure this out using the understanding of our external and internal activities and those run durations. And what you'll find is that when you do that, Data Factory, it's quite cheap to run. But of course, Data Factory is just the orchestrator in this scenario. There is lots of other things we need to consider. All of that compute that I just talked about, that is where the real cost is going to come. So when whoever is paying your Azure subscription bill gets that invoice from Microsoft, I would expect Data Factory is a long way down on that list. It will be those compute services that come up there. And you could say, well, I can now control those compute services as part of our pipelines. And that's something that we should be baking in once we're dealing with this in production. Okay, let's move on to the next topic, the next short story that I want to share with you. And this one relates to now scaling out our execution. So hopefully, given what we've talked about so far, this is kind of a good sort of natural next step in things that we can think about within our data factory. So scaling out our execution, the starting point for this, as you probably already know, within our data factory, we have this for each activity. And this for each activity will accept an array of values, which I might get using a lookup activity, but use a metadata activity or something else if you prefer. And that for each activity will then iterate over some other work, some inner activities, and it will use the item iterator to pass those values from that array. Now that's all good, and we'll think, well, why are we talking about this? We're thinking about scaling out our executions. Well, as I'm sure you probably know, by default, or perhaps when we think about a for each loop, we might be thinking about something that happens very sequentially, one after another. And yes, we can do that. But better within our data factory is by default, that for each activity is going to scale out. All of those threads, if that's a reasonable way to describe them, are going to run in parallel if possible. Data Factory will take that array of things to iterate over, and it will spawn all of those threads in parallel, and it will run all of those processes in parallel for us. So that's a really nice feature that we get out of the box. Do just bear in mind that if you're in debug mode, you might still be forced to do this sequentially, because if you have an execute pipeline activity within your for each, it will detect that and it'll say, okay, I'm not quite sure what you're doing here. We're running in debug mode. I'm still going to force you to do this sequentially. So just bear that in mind. But by default, we can have 20 parallel threads, 20 parallel processes running, or up to a maximum of 50. So this is quite handy. This is a nice feature to have. So let's think about that then. Let's apply that to a scenario. Let's apply that to a problem that I see happening quite a lot. And the problem that I'm going to use and the story I'm going to use to tell you about this is with SIS packages. Now, I know SIS packages are definitely a technology that are perhaps in the past, but I'm going to use them just to frame this problem. The point and the pattern I want to show you can be applied to everything. I'm just going to use SIS packages now to make the point. So if we want to run an SIS package, we use Data Factory, we deploy our SIS integration runtime. And what we have in there is a cluster of compute. We can have 10 nodes within this cluster of compute, which are basically just SQL Server virtual machines underneath. And if we want, we can have 8 packages running per node. So we could say that our SSIS-IR and its cluster will support 80 concurrent packages running. Nice. The pipeline I've got there, though, on the slide, of course, that's one activity running one package. So, of course, there's a mismatch there. So that max stop of 80, we're not going to be able to achieve that with that single activity. So what do? This is where we need to think about scaling out our execution. So possible solutions. We could say, well, I'm just going to use a parent SSIS package that's then going to call all of those child packages. It's a fairly common pattern. But unfortunately, within Data Factory, it's not a pattern that's going to work, because it'll be that parent package that gets that 1/80th of the compute. It will not scale out those child packages across the cluster we've got available. You'll need to refactor your packages if you want that, making the activity the main the thing that calls the child packages. So that pattern isn't going to work. We could say, I know I'm going to have a single pipeline. I'm going to have 80 activities in there, all calling one SIS package. That's going to scale out. That's going to run on my cluster. No, it's not. That doesn't work. You can only have 40 activities per pipeline. So, we're only going to be able to use half of our cluster again. So that pattern isn't going to work. You could say, well, okay, Paul, we've looked at the for each activity. We could use that instead. Yes, but as I've perhaps already shown you on the previous slide, you're then only going to be able to run 50 packages at once. So that's also a problem. So again, we're sort of thinking about scaling out our execution. So those patterns aren't going to work. Let's think about some possible solutions that might. Firstly, we could refactor our packages and our pipelines to something like this. We could say, I'm going to have a parent pipeline calling 2 child pipelines, each with 40 activities in. Yeah, okay, that works. You'll get a bronze tick for that. So we could restructure our pipelines in that way. Of course, it's not very dynamic. It's very static. It's very manual. We're going to have to go in and do that for all of those activities. Or we could say, I know I'm going to have a single pipeline. I'm going to have some for each activities in there, maybe 8 of them. And then I'm going to have each for each activity responsible for running 10 packages in a batch of 10. And yeah, sure, we could do that. That would work as well. But a bronze tick, still not ideal. And still, hopefully, this is where I'm making the point that we need to think about scaling out. We could say, well, Paul, I'm not going to use all 10 nodes within my SIS cluster. I'm just going to have one huge node. And then I'm going to have that parent-child package scenario that I've been used to. Sure, you can do that if you wish, but that isn't really going to be obviously that dynamic either. And all you're really doing then is paying for a huge SQL Server virtual machine that you can't actually then really access. So again, a bronze tick, perhaps not the best. We can do better. So solution number 4, and this is where I want to talk about this as more of a general pattern, but of course now within the context of SIS packages, because it's an easy problem to solve. And I'm going to say that let's have another database maybe that sits alongside our SIS DB. And let's say that we're going to use that as our metadata store. We then have this concept of buckets, which I'll show you in my demo. And we assign our packages to these buckets. Maybe we have 50 of them. And then at runtime, we get that array of buckets and we give it to for each activity. We then have an execute pipeline. And then within that execute pipeline, we have another lookup and we say for that bucket ID that you've given me, then return me an array of the bucket contents. So you see that we then have a second level for each activity in there. And then we say at that level, run my package. So we have a for each activity level 1 that gives us that max degree of parallelism of 50 parallel threads. We then have that for each activity level number 2. And then that gives us another ability to scale out for another 50 parallel threads. So the simple maths, of course, is that with that nested for each activity pattern, we could, if we wish, achieve this greater level of parallelism of 2,500 packages or things running. So that nested for each pattern is what we can perhaps now use and what we can think about when we're talking about scaling out using Data Factory. So just to kind of bring it home and summarize that if we were going to do that and we were going to use an SIS DB, a SQL DB as our metadata store, this is when we perhaps then need to think about our concurrent connections relating to the service tier, because an S9 SQL DB will then give us the maximum or give us that concurrent level of connections we need to achieve that. So we could come up with this as a new working definition, a parent pipeline with that first for each activity, a child pipeline with that second level for each activity. And now, of course, we can run lots of things in parallel. We can make best use of that SSIS-IR. So that was within the context of SIS packages, because that 80 packages running in parallel is a nice way to frame the problem. But let me show you a demo. And in this demo, I'm not going to use SIS packages. At that lowest level in my activities, I'm just going to say we want to do stuff. In my case, some stored procedures. So let's take a look at it. And let me share my desktop like this. So what I have here is a SQL database, which hopefully I've remembered to scale up. Yes, I have. So in my case, it's an S6 SQL database. I have a table that I've called buckets, because I'm not very good at naming things. I have 50 buckets of things that I want to do here. I then have a table of processes. In my case, 500 processes of things that I want to do. And these processes are, in my case, just stored procedures. So within my SQL DB, I've got 500 stored procedures created and registered in this table of metadata. Each stored procedure is doing something fairly boring, actually. Of course, the point is scaling out here, not necessarily doing some work. I've got a wait delay in there, and I'm then inserting a stop word from the dynamic management views of stop words with just a random stop word that I want to put into this data dump table. So nothing very exciting about the work I'm doing. Of course, the point is that the parallel processing. So I've got my 500 processes. I can then map those processes to buckets, and we could just round robin them if we wish. So bucket ID number 1 is responsible for these sets of processes, and so on. And we could, of course, set that at runtime as well if we want. We could use the processing duration and history information to decide how we distribute our work across those buckets. And then we have our output table, which I think has probably got some data in it from when I ran this earlier. So I'm just going to truncate that just to prove there's no cheating. And then let's turn our attention to Data Factory, which I'll bring over here for you. So within my Data Factory pipeline, I have that pattern that I talked about in the slides. I have this scale out level 1, as I call it. And this is resetting those processes versus the buckets. It's getting those bucket IDs using a lookup activity. And then it is that bucket ID that is being provided to our first level for each activity. So then within there, we have our child pipeline, our level 2 scaling out, and that accepts as a pipeline parameter just that bucket ID. So that one bucket ID, and then it will do another lookup to my database and say, okay, for that bucket, get the contents of that bucket. And it's that contents that we provide to our second level for each activity. And within there, finally, we have then a process. Could be a stored procedure, could be a SIS package, could be an Azure function, whatever it is you need to do here. And in my case, it's just dynamically calling that stored proc with that process ID because that was the naming convention that I used. So I can come back up to the top level and I can then trigger this pipeline to run now. So this is going to scale out that first level of 10 buckets, sorry, 50 buckets. It's then going to scale out at that second level of 10 processes per bucket. So I'm going to create 500 parallel connections to my database to insert that stop name, that dummy value. And that's then going to go and run. So if I look at my monitoring page, you'll see straight away, I've got the scale out level 1. It spawned those 50 level 2 processes. And then if I just pick on one of these and maybe refresh a couple of times, it's then going to scale out and run each of those processes again. So what it means is that, of course, now with that simple pattern, that 2-tier for each activity, I can then achieve that, that huge set of parallel work, and then just using some metadata to drive it and some fairly dynamic data factory pipelines. So if I filter this to my scale out level 1, I think this takes like a minute and a half when I did this. 1 minute, 20 seconds. So 1 minute, 20 seconds to do 500 things at once. 500 very small things, I accept, but that's the argument of scaling out versus scaling up. So I've done lots of very small things. So if I just query my tables again, I've got 500 records. I've got 500 stop words that have been inserted into a table. Okay. So hopefully a fairly simple demo, but hopefully a pattern that you can perhaps reuse and one that's quite useful when you're thinking about scaling things out. So let's turn our attention back to the slides. And as you may have noticed on this slide here, the code of things that I just showed you in that data factory, please feel free to go and get those out of that GitHub repo as well there. Okay, moving swiftly on. The next thing I want to talk about is metadata-driven pipelines. Now, I showed you metadata to drive our scaling out process, but what else could we do here? Well, the problem statements I'm going to use for you now is when it comes to structuring our data factory pipelines. Not just doing some work, but what do we actually do when it comes to creating our pipelines within our data factories? And hopefully a fairly common scenario. I have my data lake. I have some layers of my data lake where I want to mature that data to enrich it or whatever. And we have our data factory sat there. And I'm going to say that for 3 business processes, I'm going to create 3 pipelines, 1 for each. I'm going to have some activities in there, and those activities are going to be used to get my data from landing to that serving layer. And we can say that's going to happen in a horizontal set of processing planes. And that's fine, that's okay, that would work. But then what happens is invariably that we end up with a dependency. So business process number 1 requires something from business process number 2. A late arriving fact or an early dimension, however you want to call it. So that horizontal processing isn't going to work. We say, fine, I will use vertical processing planes. I will process all of my activities from landing to cleaned, and then cleaned to transformed. So we do pipelines A, B, and C instead. But of course, we end up with another dependency. That's not going to work either. So those vertical processing planes aren't going to help us. So then we say, fine, I'm going to go super granular. I'm going to have a one-to-one between my pipelines and my activities. And then what I'm going to do is I'm going to chain everything together in my data factory. And I'm going to have a new sort of bootstrap pipeline that's going to sit above that. And that's okay, you know, that will work. That will get you some of the way there. But I'm talking about this in the context of 3 business processes. That's not a lot. And what you may be thinking about, and I've already mentioned this, is that you will have a limit of 40 activities per pipeline that you're going to reach. So that could be a problem for you. So say, okay, I'm not deterred. I'm still going to try this. I'm going to refactor my processes. I'm going to group together the ones where I don't have dependencies. And I'm going to have only low-level ones where I need to control the dependency. And I'm going to chain them all together. And I'm going to have a new working definition that says a grandparent for all the processing, parents to consolidate work where I can group it together, and then child pipelines where I've got those low-level dependencies. And that's okay. But, you know, again, it doesn't make things very easy. It's not very manageable over time. So let's think about something that we could do better. And the solution that I'm going to say to you is that let's couple our data factory, in my case, with a SQL database, like we did in my demo, but now for perhaps the purposes of a wider set of processing. What else can we do here to drive our pipelines? So if we explore that solution in theory, and we say, yes, I've got my horizontal processes, I've got my vertical processes, but now I've got this metadata to support both of them. So I'm going to say, let's have worker pipelines for each of those processes. You know, you can go modular here or granular, you know, as you prefer. I'm going to say, let's have execution stages. Stages that represent those vertical processing planes. Then I'm going to say, let's have a pipelines table as well that represents those horizontal processing planes. And we can then do something really advanced. We can join 2 tables together. Crazy, right? So we join those tables together. We get our new set of metadata. We have execution stage number 1, which runs pipelines A, B, and C. We then have a downstream execution stage number 2 that runs pipelines D and E, etc., etc. You get the idea. So we can use that metadata to drive all of our processing and to handle those dependencies for us. It means as well that within an execution stage, we can also scale out. But there is one more problem that you may have thought about, and that is the call child pipeline activity does not support dynamic content. We cannot inject into that with an expression via the Data Factory UI. So we need to think about using a third set of tools here, or third set of options. We could, option 1, use a web activity to hit the Azure Management API to run that worker pipeline. Sure. We could, if you wish, use Logic Apps to call that worker pipeline, also acceptable. Or what I prefer is to use Azure Functions. They're first-class citizens within our data factory now, and then we can actually reach across, you know, Azure subscription and tenant boundaries as well. So to complete that solution, to complete that picture, I'm going to say, if we want to handle how we structure our data factory pipelines for dependency reasons, for scaling out, for whatever, let's couple our data factory with some metadata, and let's use an Azure Functions app to sit there as the middleware to then interact with our worker pipelines. Now, if you're sat there thinking, yes, Paul, this is brilliant, this is exactly what I need, then good news. I've already built it for you. And if you go to procframework.com, you will find here a framework very much as I've described to actually support you and use. It's on GitHub, it's open source, it's not a sales pitch. Feel free to go and make use of it as you wish. Things like restartability and email alerting, and you can call those worker pipelines across Data Factory, across Azure tenants as well, if you wish. So that framework's there if you think that this is a problem that you need to overcome. Next up then, I think our second to last topic, deploying Data Factory. This is an interesting one. This is obviously a lot more relevant to perhaps thinking about Data Factory in production. So let's dive in. And let's start with a very simple scenario where we have one data factory that we have to look after, and we can use it in that debug environment, and we can say that, yes, that is going to be dev. And if we wish, via the Data Factory UI, we of course have the publish button on the toolbar. We could hit publish and say, yes, that is Data Factory in production. Now that's fine. And what I'm going to say is that using a single data factory is going to be option 1. Not ideal. I'm going to give you 4 options here. This is the starting point with a single data factory, and we could do that. But of course, we're good developers. We want to do something better. So we say, actually, I'm going to have multiple environments, dev, test, prod, or however you want to call them. And I'm going to say that option 2 is to use the Azure ARM templates to deploy your data factories to those multiple environments. And that's fine. We could also do that. That's option 2. Excuse me, my throat is drying up. So let's explore option 2 in a bit more detail. Let's take our option 1 scenario. And then what I'm going to say to you is, let's think about just getting our data factory source code. You might think this is obvious. Well, sadly not. So if we want to get our source code to deploy our data factory to those multiple environments, we could use our master branch or our feature branch, and you will then get a set of data factory artifacts in there, one for every thing, every component, every resource within your data factory. Fine. We could, option 2, if you really want, is actually download an ARM template from the data factory UI. Okay, fine, option 2. And of course, in this scenario now, our single data factory, that's just our dev environment. So of course, we have our debug service, we have our dev service, and we have this publish scenario. Now, what actually happens behind the scenes, as you may already know, in your repository, Data Factory creates its own branch, normally called ADF_publish. And when you hit that publish button to take those components from your debug environment to that published resource, it then creates another set of artifacts for you. And it is those artifacts, those third set of JSON files, is what you actually then need to use when you're thinking about publishing to multiple environments using the ARM template. And it's that file there, ARM template for factory, that we need to think about. So let's take option 2, let's follow it through and say, yes, I'm going to use Azure DevOps. I'm going to build those artifacts or do that publish operation, which is going to get me that ARM template for factory. I'm going to say, let's have a release pipeline. Let's have one called test. And we use the Azure resource deployment, the ARM template deployment task. We have some scope variables. We override our data factory name and maybe some other stuff. And we have a good branching strategy. And we get our test data factory. Maybe we clone the pipeline. We do the same again. We have some approval gates, so we don't have developers doing a publish from the dev interface that then deploys things. So we approve those, we take control, and we get our production data factory. Now that's fine, option 2, we could do all those things. But with option 2, because we're using the ARM template, it means that our components within our data factory We have, of course, 5 of them, our link services, datasets, pipelines, triggers. We can actually only parameterize the link services. They're the only things that get exposed in that ARM template if we were to use the one that Microsoft provide us. So not ideal. Maybe for a large data factory, we want a bit more control. So I'm going to say now, let's think about option 3. Option 3 is where we want to perhaps parameterize and have variables for the content of all of those data factory artifacts. So instead of using that ADF_publish branch, let's maybe use our master branch, or develop, or whatever your branching strategy is. But those artifacts that I talked about, where we have one JSON definition file per data factory component, let's use those instead. Let's use those definitions to deploy our data factory. If we do that, let's not use the ARM template deployment tasks. Let's instead use PowerShell. And we have a commandlet for every data factory resource type. And we can then provide those definitions to that commandlet and say, go and set that resource for me. So that is then going to give us a lot more control. We can then just deploy the data set we want, just the link service that we want. We can supply parameters to it, and we can think about overriding things, and we have that control. Now, that's okay. Option 3, that's good. Maybe it's better than what we had with our ARM templates, but there's still some caveats here. And those caveats, quite simply, are that we then need to handle our own dependencies. So we will get a deployment time error if we try and deploy a data set where the link service does not already exist. So we have to handle those dependencies. And of course, the PowerShell set commandlets aren't going to do any deletions. We will have to handle the manual deletions of things that we no longer want in our environments as well. So still not ideal. So let's think about option 4. Now, option 4, we're still going to use those JSON definition files, but with option 4, we're going to use a PowerShell module that my friend Camille has created, azure.datafactory.tools. It will wrap up all of those commandlets that I've already talked about. It will give us that dependency handling. It will give us that level of abstraction perhaps that we want. And we can then use the single commandlet to publish our data factory. We can point it our Git repo. We can tell it the folder that we want to use, and we can go and work with it. What Camille's also done is he's taken it one step further. If we're using Azure DevOps, we can use a custom task in there as well called Publish Azure Data Factory. It wraps up that PowerShell. It makes things nice and easy for us, and we get that control. We can override all parts of those JSON files if we wish. So yeah, it's something to go and check out. So those are 4 options. Just to summarize, a single data factory, obviously not very common. Hopefully we have multiple environments here. Option 2, using the ARM templates if we wish. Option 3, with the PowerShell commandlets and those JSON artifacts, obviously quite a bit of effort required to you to go and code that. Or option 4, using a PowerShell module that wraps things up and that custom DevOps task. So 4 options for deploying our data factory. I definitely use option 4, especially these days. So much easier. So just to kind of bring that together then, DevOps for data factory, if we're thinking about it as a complete story, these are the questions that you need to go and ask yourself. Go and ask, about your branching strategy, the tools, the environments, the method of deploying data factory that you want to use, and what artifacts you're going to use to do that as well. So that concludes that last second to last short story. My very final one is much shorter, and that comes down to best practices, which is definitely a hard one to think about. So what I've done is I've fairly lazily, if you like, summarized the best practices that I think we should be using here. And the reason for me doing this and cheating slightly is because I've got a blog post out there called Implementing Data Factory and Best Practices. And this blog post now gets somewhere in the region of about 1,000 hits a week. So, you know, a very popular blog post. And what I've got on there is, I think, these 24 points now around things that you can do for your data factory. I appreciate I've not covered everything in this session, so I'm kind of steering you towards this blog post as things like testing, things like monitoring and security. There's sections on there to give you some more advice and guidance. What you'll also find on there as well is a PowerShell script that I've been working on and playing with and creating to try and automate some of those things. So you can take an ARM template from your data factory, run this PowerShell script against it, and get some automatic checks of things in your data factory that could be missing or could be done better. Not things that are necessarily going to break it, but things that, you know, if you want to achieve those best practices, go and check that out, go and have a look at them. And I think given that, with 3 minutes to spare, I will say thank you everybody for listening. There's my contact details here and on LinkedIn and Twitter. The GitHub repositories, as I already mentioned at the start, the community events one is available if you want to go and get a copy of the slides. There's already a PDF there. A common question I always get asked is, where do you get your graphics and things, your icons from? If you go to my content collateral repository, feel free to download a Visio stencil of all those Azure icons if you want to, you know, make your own pretty pictures. That's what I tend to spend my life doing. And the last repository there is for that processing framework, if it's something that you think you perhaps need in your data factory. So thank you very much, everybody.